everybody. Today we are going to see about the radiation mechanism of a dipole antenna. Now we are going to see about the definition of the dipole antenna. Already we know the definition of an antenna. Antenna is a mean for radiation or reception of radio waves. So here one more word is added, that is the dipole. Okay, so di means two, so it consists of two poles, that is a pair of equal and opposite charge. And here you can see two dipole antennas, okay, which are center fed. This dipole antenna consists of three elements. The first one is the sinusoidal AC source, the second is the transmission line, and the third one is the dipole antenna. Usually the length of this dipole antenna will be lambda by 2 and it is center fed. That means this transmission line is connected at the center and it has a insulator also, and with the help of that center connection this AC signal will be applied to this dipole antenna for radiation. Here you can see a family pack of ice cream. You can assume it as a conductor. Now the charges are neutral. You can take a scoop of ice cream and put them on other side. Scoop of ice cream can be considered as electrons or the negative charges. Because of this, holes are created at this end. Now you will get the formation of field lines because of accumulation of charges on one side, and they tend to flow from this end to that end in order to fill up the vacant places or the holes. So the field line will be in this direction. Once you get all the holes filled up, the conductor attains its neutral position once again. The conductor becomes neutral again. The same concept is applicable for the working of dipole antenna too. Now let's see how it works. The AC source is connected to the transmission line. During its positive half cycle, positive charges accumulate at one end during the time period 0 to T by 4, where T is one time period. During this quarter time period, because of charge accumulation, the current attains its maximum distribution and the field lines travel a distance of lambda by 4. So this is your field lines. These field lines travel a distance of lambda by 4 radially outward, and the number of lines depends on the magnitude of the AC source. During the time period T by 4 to T by 2, so this is your T by 2 time, the signal reverses its direction. See, here it travels downwards, so the signal reverses its direction. Hence new lines will be formed. So you can see here this new lines which are shown in the blue color will be formed. This happens during the time period of T by 4 to T by 2. So at that time this red field lines which were created or which were formed during this first quarter travel a distance of lambda by 2, and this blue field lines they travel at distance of lambda by 4. This simulation shows the voltage distribution and the current distribution of a dipole antenna. This end gets the positive charges, this gets the negative charges, and voltage will be maximum at the end of this dipole antenna, which is shown here with the pink color, and the current will be maximum at the center. The current will be flowing in this direction like this, or it will be flowing in this direction, okay, depending on the polarity which is existing at the ends. So this currents are shown with the help of this blue arrowhead. So we can say that during the positive half cycle, positive charges accumulated at the left side and the negative charges accumulated at the right side. So here you have the voltage maximum. This is positive voltage maximum, and at this end it is negative voltage maximum, and no current will be available. After that, the current starts flowing because of this potential difference. So it start flowing like this. So you will be getting this current distribution, and the current will be maximum at the center. So here it is getting reduced because of this negative charges, and the as the opposite charges attract each other, they get neutralized. So this current is getting maximum and maximum till all the charges vanish. So here no charges, so you'll be getting the maximum current at this point. During the negative half cycle, this end will be having maximum negative charges, and this side positive charges accumulate. So here you have the maximum negative voltage amplitude, and here you have the positive voltage appearing, and no current will be there. After that, the same concept reverses. Okay, so opposite charges, they tend to neutralize, so the current will be flowing in this direction. So you will be getting the flow of current. So it is getting rising like this in the opposite direction. Okay, so you will be getting a maximum. So now we'll see what happens. So we'll see what happens at t equal to t by 2, where t is the time period. This is your dipole element, and here no charges are accumulated because they are neutralized. Because of that, these lines which were already formed, the red lines and the blue lines, they combined here to form the loops, and they get detached from the dipole element. So after that, if you continuously apply this AC signal, you will be getting the loop formation, which will be traveling away from this dipole antenna. Here also it happens at this side as well as this side. And we'll be having the magnetic field lines which are encircling this dipole element. And we can also see about the current distribution of a linear dipole antenna. And when this length is very much lesser than this lambda, where lambda is the wavelength, you will be getting the hypothetical current distribution like this, but in practical we'll be getting the current distribution like this. The second case is when the length of the antenna is less than or equal to lambda by 2, this semicircle formation of the current distribution will be there. And if we go for the third case, in which the length of the antenna lies between lambda by 2 and lambda, at that time the current distribution will be like this. It's like a big curve. So at this point we have a dip. Okay. And this is the fourth case, in which the length of the antenna is less than 3 lambda by 2. In this case, you will be having 3 lobes like this. This is the current distribution. So at these two ends as well as here, we'll be having the current distributed. 3 maximum occurs. That's all about the current distribution or the radiation mechanism of a dipole antenna. Thank you.